Hi everyone, I hope all of you can hear me and see me. So before I start explaining things, I want that you people tell me that I am audible enough and of course I am visible. That's also very important point. So I'm just waiting that all of you can hear me and see me. Can you all? Hi Manoj, hi Nagaraju, hi Chandru, hi Charan, hey Shahrukh, hello. Thanks for letting me know. My voice is low. Okay. Is it fine now? I was speaking a little slow, not that loud. So fine. Okay. I hope I'm quite quite clearly visible. Hey, good evening. Is it fine now? The voice is okay, or do you think it is still low? If it is, let me know. Good evening, Purna. Hi, Lohitaksh. It's okay. Great. Okay, it will be fine when I'll start teaching. If it is a little bit low, then I'll later on increase the volume. Okay, let's see. Okay, so as you all aware of, this is the practically platform and we are doing the Maths Beyond Book course, and we, as you know, are offering this summer workshop where a lot of courses are running. In this course today I'm going to tell you the project. There are 5 questions you have to solve, and there are perks attached to it. So the top 10 projects will be selected and you'll get a 6-month superhero subscription, which is our kind of offering, which you can find details on the app. uh, Also, if your attendance is good, then there are some XP points which are actually encashable into the buying the courses in the later part of this session. Okay. uh, by the way, one more thing, there are certain rules and these are very important that you do that, otherwise your eligibility will not be complete and you will not be entitled for any of the rewards. And this is that your attendance should be at 80 to 100%, and you have to take the screenshot of your project or of the class, whichever thing you find, and tag it with, so you have to set it to @practically app. Okay, on all the social media platform, and you have to use the hashtags practically and hashtag summer workshop. This is very important. This is our Facebook and this is our Instagram login. You can find these in the description of, in the video description also. So in the video description you'll find all the links. Okay, please use those links and go and post the screenshot and tag it practically and summer workshop hashtag. Okay, voice is low, sir. Okay, let's just quickly correct the voice then, so that you people can hear me then fine. Okay, what about now? Can you all hear me now fine? I don't know the why does this becomes like that. Is it okay now? No hissing, no nothing like that, correct? It's perfect. Okay, then it is fine. So let's now jump back to this. Okay, one important point. In this, remember one more thing, that your questions you should be doing in a proper way. Okay, so those questions, when you are solving it, write it in a proper format, clean writing. I don't mean good handwriting, I mean clean legible handwriting. And then you have to, and the link is there, you have to upload that your PDF or whatever that in the place and post the link. So you can post it on your Google Drive. That suppose you made a like a PPT or like maybe a PDF or a Word file, whichever thing you find comfortable. Do that, save that file in your Google Drive and share that file access and paste that link in the form which is attached in this video description again. So you'll find the form, in that there will be one link to be pasted, which link will come from the Google Drive. I hope all of you know how to upload on Google Drive. Yes, you people are smart, I guess. So you people know now. You just have to go onto your Google account, your Gmail account, upload it on the drive, then right click on that file and click share, and then allow it to be downloaded or editable, so that I can edit or I can download it easily and see it, and then you just post. post it there, the link, copy paste it here, and rest all the details you have to fill, which course you are and what's your name and all the basic details, so that we can find you. Otherwise we will give the reward to someone else, or I'll take it. Okay, so we are going to do the session 12 now. Hey Tejesh, this is just a like a project thing, and I was telling about that today I'm going to give you the project questions, and you have to upload the project in the Google Drive after taking the snips properly, and then you have to share the link. The form which has to be filled is in the video description. Okay, you get it now, Tejesh. You can rewatch the video after it is streamed. Okay, these are by the way, today is we are doing practical geometry and construction. I'll try my best that I make you understand a few new things if you were not aware of it. If you were already aware of, take it as a revision. By the way, these are your questions. Just quickly take the screenshot. I hope that I'm not overlapping on any question. You just have to take the screenshot. I am going out of the frame so that you don't take my picture as screenshot. It's fine. Now you take the screenshot of these questions. Just quickly take the screenshot. You know how to take a screenshot. It's a very easy way. And the first question is based on rational irrational. The second question is based on linear equation. The third question is based on probability. The probability I have not taught you, but you know the probability, lot of things. It will be taught in the last session on 28th May. So you can submit by 28th if you wish to. Okay, then these are the second question. Now these are more like of like the basic thinking. This question is based on the factors approach and also on the number theory. The number theory I have already covered. Remember one question I taught you that some should be integers and like that. A little bit of that way you can apply it here a little bit. And in this question it's based on geometry, and geometry we are covering this, so you should be aware of like triangles and squares, and you should be aware of the basic idea of a square and a triangle. Okay, you should be aware of the right angle triangle, and it is just telling you there is a right angle triangle like this. And yeah, so how we have to submit, Tejas, that I explained, you have to solve it on a like a good piece of paper. Take a blank sheet, prefer that thing, and write the solution properly. Okay, then take the screenshot, clean screenshot, then paste it on a like a word file. All the screenshot you combine on a word file, and then save that word file by your name. Please use that your name, and you only write, say let's say your name is Jimmy. I hope no one's name is Jimmy, but fine, Jimmy, and your mobile phone number. So my mobile phone number is, are you, no, I'm not that gullible. I'm not writing my phone number here. So you write your dot and phone number like that. Jimmy, don't write a dot here. Let's remove that dot. Jimmy, and then you write your mobile number so that it's easy to be recognized. Even though your names will be same, the mobile number of course will be different. Okay, use that way so we can easily reach out. Okay. Um, Also fill the form, and then you have to like copy paste it, the link. Okay, the link, yes, in the Google Drive you have to upload, then right click on it, share it, and copy that link and fill in the form. The form link is in the video description. Okay, the form link is in the video description. In the very end of the video description you will find the form link. Is it fine? I hope everyone has understood this. Yes or no? Yes or no? Yes, everyone has understood it. Okay, have you all taken the screenshot? Remember that the first three questions, this come from the rational irrational, so you should be aware of what's a rational number. It's a very good question. It's also in, I think it's maybe it's in RD Sharma or somewhere, but it's a very good question. It's very different, and this is based on linear equation in one variable. A little difficult, I'm telling you. This plotting is difficult, but let's see if you can do that. Linear equation in one variable, the graphical approach. This is based on probability, which I haven't taught you. This is based on geometry. You can just apply your little brain, your smart little brain. And then you have, this is on factors and number theory. Basically, it's on number theory. Okay. So it's a very good question. Let's see if you can all answer it. Rational, not retinal. Okay, great. So today we are going to do, hey, wait, all my slides are blank. Oh, so today there is no slide. Today I'm not teaching you on slides. Today I'll be like discussing with you a few things, and I'll be drawing in reality. Okay, in reality, like you do in your piece of paper using your compass protector, I'll also do that. How? Let's see later. But there is no slide today. Okay, first of all of you just quickly tell me, do you know, all of you know how to draw angles? Just quickly, so we can wait. We cannot wait. We should not waste our time. Okay, so all of you know angles. Okay, all of you are aware of one thing, that 60-degree angle, correct? This is the easiest one we draw. Yes. Okay, so now let's start drawing a 60-degree angle. Okay, first of all, let's get a ruler here and let's make a line. Any line, it doesn't matter how much long it is. Okay, now we put our compass. Okay, okay, and we cut an arc. Let's keep a smaller arc, like this one is okay, fine. Now we make an arc. Okay, we get this. The next step is to put it here and draw another arc. Super. Then we go here and we just remove this, I don't need it, and we then go and draw a line. Let's say in a blue color. I don't need this, white has come. Okay, now you know that, now you all are aware of that this angle is 60 degrees, correct? Yes, we all know this. Do you know the proof why it is 60 degrees? Why it is 60 degrees? Preetha, I have told it like 2-3 times, so just let the stream end and rewatch my video for the first 10 minutes, approx 10 minutes, and you will get everything. Okay, or I'll re-explain it in the end session, after the session. Okay, Pythagoras, no, you can't apply Pythagoras here. Okay, equal measurements, Charan, I understand. Okay, let me just name it so that we can easily denote what you mean by equal measurements. Okay, why this is 60 degree? So ABC we have got it, because it is 1 by 6 of a complete circle. Deepika, how you know it's 1 by 6? Just because I will go one day and I will make a circle like that, and I'll make a circle like that, and then I will say, hey, I'm putting one arc here. So let's say I'm going here anywhere and I'm putting one arc. No, not like that. Yeah, I'm putting one arc here and then I'm putting one arc here. Okay, and then I'm going and putting one arc here, like that. Is it like that? Okay, let's see if I get your point clear. Okay, wait. Okay, this is what you mean. I'm just trying to get what Deepika has said. I'm just trying to like follow her lead, because she just told me like this and I'm like okay with her in this scenario. Like, yeah, this, she's saying it correct, perfectly fine. So okay, okay, do you mean this, Deepika? Because now it is like, now every part, if I notice now, is yeah, I don't need this. Yeah, so this is like one, because this is now x distance, every distance is x, and we got a 6 distance x, and that's why. Okay, okay, fine, I get it. You mean like this way. I think it's not a wrong approach to solve it, because the complete angle is 60 degrees, and you will read in circles that equal arcs subtend equal angles at the center. That's a theorem also, that equal arcs, in class 9th I think so it is taught, equal arcs subtend equal angles at the center of a circle, subtend equal angles. Since the arcs are equal in length, therefore the angles must be equal. Now you know that if all the angles are equal, there are 6 angles and sum is 360, so each angle is 60 degree. You people are smart. I have so far found this already. Okay, so now I understand this I totally understand. Okay, but is there any other way? I don't want to go into this bigger circle. Can I just prove it here? Okay, let's see how. Okay, all of you wait, understand. You said, or we said, that AB is the length of an arc. You remember I didn't change the length of the compass, it was fixed. So let us say this was x. Now when I gone from B to C, I made an arc. Now equal arcs have equal chords, like that. Okay, so this length indirectly, okay, this length would be how much? X, because this is also the same length, because it's the same circular radius. If you can just imagine, if I would have drawn a circle completely, the radius would not have changed, correct? Okay, so now do you see this, that this is x, this is x. Okay, now x and x both are equal. Okay, now in this scenario this is also kind of x. Why? Because this is joined by the same length. Yes, equilateral triangle, obviously everyone got it. Superb. Okay, now I hope everyone has got this. What is the project? Hey Jagruti, don't worry about the project. I'll show you that screen again. Don't worry. Yes, and now this is obviously this is 60-degree. I hope everyone has understood it, and that's done. Okay. Now let us clear this. Okay, we know how to draw 60-degree. We people are smart. We people like you and me should also, you should count me now. I'm also smart. Okay, now you know that we got this 60 degrees. Do you all know the angle bisector drawing method? Yes or no? Yeah, there are total 5 questions, and please don't ask anything about the project currently. Like I just miss it. I just learn all the questions, and therefore I bring so blank screens today, and I will forget questions. There is no reference, okay, today. Okay, so angle bisector, you know, this is a very simple approach. You remember that at any stage you are not changing the length of the arc, or the arc length, whatever you call it, the arc length. The arc length has to be constant. Let's begin. Okay, let's begin with the arc length. Okay, let's make a line, simple line. Let's make a line, bigger line. Okay, let's make one arc. This much is big. I think this is big. Let's log this and make it. Let's make a 60-degree. Hey, yeah. So let's make an arc of 60-degree. Done. Now you remember you are bisecting it. The bisecting happens from where you start and this. Okay, what you do, you can take more than half of it also. That is correct. Actually in NCERT, I guess that's mentioned. Okay, so you go like this and you go like this. You can change the arc length here to more than half. It will bisect. This is how you used to bisect a line. Remember, perpendicular bisector of a line. How you used to do, you used to make the length and take the more than half of the length, and then you have to draw the arc, kind of. So you can do both of the ways, and then what you do, you join it. Okay, so let's join it. Yeah, okay, this is what is, no, it's not 15-degree, it's 30-degree, because this was first 60-degree. Okay, let's see whether I am correct or not. Okay, I'm bringing my protractor here, and see, perfect 30-degree, and this is perfect 60-degree. Can you notice this is perfect 60-degree, this angle? Notice this angle, this is 60-degree. You read from the below line. I hope you all know how to read a protractor. You always read from the side which is your zero demarcation. So zero demarcation is on this side, so it's the inside scale we are going to read. The outside scale we are reading when we are taking from that side, that then we read zero from there, correct? My voice is low. Yes, Deepika, 15-degree. Yeah, that's I was about to come. That's true, Deepika. We only can make 15 degrees multiple. Is my voice still low? Just quickly tell me. Just quickly tell me. Is my voice still low? I'm still messed up. Jagruti only telling me. Okay. Sir, your voice is all right. No, no, sir, it's okay. Uh, Let me just do one thing. If someone has having that trouble. I hope the voice is now fine. I have increased it a little bit more. Okay. Still not clear. Okay. This should bring the voice perfectly fine. Okay. Okay, fine. Now, remember one very basic point, and that one very basic point is uh, that this, what you see is 30 degree, and I can further bifurcate is 15 degrees. Okay, so let's do that bifurcation again. So I'll bring my compass back from this place. Remember, I'm going to cut one arc from the 15 degree. This is my 15 degree arc point. Okay, this is my 15 degree arc point. So I'm going to cut one arc, and now I'm going to join it. Let's take this away. Let's bring it. Let's change the color. I don't need it. Why should pops up? And this should be 15 degrees. Okay. Hey Shruti. So now you all see, let's check whether it is 15 degree. Let's bring it here. Hey, it's pakka 15 degree. It's sure 15 degree. Let's see, can we bifurcate even 15 degrees? Can we divide this 15 degrees even further? Let's see, can we? So Deepika told me that, sir, 15 degree multiple. I want to understand why Deepika said that. So so of course this arc won't change. So let's change the color of the arc. Oh, not this one, the blue one. Yep, I don't like the red ones. So now you notice one thing. Now I have to cut it. Now you again see, we can again draw. So Deepika, where are you? You said something to me. In general, we can make anything multiple of this, but still we can go for 15 degrees. Superb. So now this is, now you see this is approximately 7.5. This is because this is near to 10. If you can imagine, this is 10, 5, 6, 7 and 0.5 kind of. Yes. So we can bifurcate it, like, but there is a limit to it, and that's why we just say that anything a multiple of 15 we can draw. So here is a trick, and I want you to understand the math behind it. The trick is pretty simple. Let's say I have to make an angle of 90 degree. This means that I have to bifurcate two angles. I have to find the average of two angles. Listen this carefully, okay? I'm telling you the way out forever. So we know that x1 plus x2 by 2 should be 90. Now this can come from very different situation. Like I can do a bifurcation of, let's say, 60 and 120, and I will get a 90, correct? Sarita, will talk about this doubt for this project things after the session. I have not remembered anything, as I've told you that I have like come with a blank slides today. Like, so I have done a lot of rectification and this will miss. Okay. So I'm just kidding. So this is what you have to understand. Okay. I'll talk about the project later. Okay. This is 90 we can get. Now in this way we can always get two answers. Now see how. If someone asks you to make a 135-degree angle, of course he is asking you to, you have to bifurcate two angles. Of course. Let's double it first. So which two angle can give me the sum of 270, and those easily can be made. Those are easily drawn. What are those two angles which can give you 270? Quickly think. What are two angles which can give you a sum of 270? You have to bifurcate those two angles. So I got 120 and 150. Didn't I? What do you see? What do you say? What do you say? Can I just use 120 and this 150? Yes or no? Correct. 135 and 135 Shahrukh won't work because you cannot bifurcate the same angle. You can. You know what you have to do then? You have to, I guess so, you have to make one top and one here, like that. So maybe like this. Somehow. This Control Z didn't work here. Okay. So maybe like this. 115, 180 and 90. Yes, Shlok. Shlok, 180 and 90 we can do. Why not? Yes. Where is 180 by the way? 180 is here. So if I bifurcate a 180 and 90, I'll get a 135. Superb. Very good. So you people now understand that there is no single rule what is generally taught to you. Correct? It's taught that the only two angles that you can bifurcate are only 120 and 150. Or it's not like this. You have to come up with something which sums up to 70 and still you can make them. If you can make them, then you can bifurcate them. Pretty simple. Okay, done. I'm not teaching you here more because I think that was enough and you people know about it. Only the concept that might have been skipped or you missed it somehow. Next blank slide. Okay, talked about angles. Let's talk about some lines. Okay, you know how to draw a line segment. That's the easiest thing to draw. Okay, do you all know how to draw a perpendicular bisector? Yep, you all know. Let's quickly understand. Remember, a perpendicular bisector. Okay, just get rid of everything. Okay, so a perpendicular bisector is basically a line which divides a line segment. Remember, it's a line. Perpendicular bisector is not a line segment. That's very important to understand. Perpendicular bisector is a line which divides a line segment or a line. A line is infinite, then you should not write that. A line segment of fixed length in two equal parts. Or any region in two equal parts, whatever region you consider. Okay, and therefore that becomes a line segment. So let us consider I'm taking a length of say 8 centimeter will be fine, or let's divide a 10 centimeter length. Okay, this is a 10 centimeter length. Okay, we have to divide it, so I'm going to write this as AB. So first, by taking more than half, Shahrukh is correct. So let's take up a compass, put it on the one end point, let's extend it more than half. So let's do it here. I hope it is fine. Okay, let's bring black color here and then just go cut an arc above. And I'm not sure how much length I will be requiring for. And we have to cut a line of arc between this. Okay, it's fine now. Bring it to, don't change the arc length because the moment you change it, it will go away. Hey, okay, fine. Thanks, I got it. And I have to bring it here. And thanks, I got it. Superb. So we finally got this this thing and we just have to join them now by this. Okay, I know that this has to be extended on the other side. I'm just telling you that I'm not doing it. You can do that. I'll leave it. So so now this should be the midpoint. This should be, hey, it's not coming. Yeah, this should be the midpoint of the lines segment, correct? Let's check whether it is 5. Hey, superb, it is 5. Yes. Okay, now I want to ask you something from here. Okay, given a triangle, do you know what's the ortho center of a triangle? Do you all are you all aware of what's the ortho center of a triangle? What's the ortho center of a triangle and how you can draw the ortho center? By the way, ortho center is a very important point. Later on in 11th and 12th you'll find that. But for now I'm not going that much detail, but yeah, centroid, no, centroid is different. What's ortho center? Anyone knows it? What's ortho center? I'm waiting for someone to do a Google search and tell me that. And by the way, this ortho is not linked to the biology ortho, which means relatable to bone and all. Yeah, altitude, no, don't know. No, intersection of medians is not slope. Ortho center is the a point of intersection of altitudes. Point of intersection of altitudes of a triangle. Okay, you people have to remember these small names. It will help you a lot in your later classes. Okay, the point of intersection of altitudes of triangle. No, Shruti, where all the medians meet, that's called a centroid, not the orthocenter. That's a very big misconception and you people have to correct it today. Where medians meet, that's called a centroid, and we'll talk about the centroid later on, not now. For this point, understand that intersection of altitudes of triangle. So consider that you have got a triangle any triangle, be it scalene or be it scalene or like that way, obtuse angle or right angled or acute angle, it doesn't matter. What matters actually, I have to draw the altitudes. Just a minute. Median is not altitude at all. This is the biggest misconception. Median is not the altitude. Median is not the altitude. Ortho center is this point. It's the intersection of the altitudes and it should pass from the vertex. Okay. Median is not the height. Hey, you people have got a very bad kind of geometrical interpretation. Let me just teach you first then. Hey, all of you, now listen. I'm not drawing anything. Before this, I want to teach you. Let me teach you then. For 10 minutes, I'm not drawing anything on this place, in this place, okay? I'll be coming back and I will be drawing it, but not now. You have a very high level of misconception. Let's begin with the journey understanding median. Okay, I thought you people were smart and you all missed it. Huh? Okay, take a triangle. Okay, you take up a triangle ABC. Fine. In this triangle, if I get the midpoint of each side, listen carefully now. I will request all of you to stop texting and chatting because you people are still missing it, and the best way to understand now is being calm and listening to me. Okay. Okay. Now consider that you have got a triangle. Any triangle doesn't matter at all. I'm not talking of any special triangle. I'm talking of a scalene triangle and acute angle. You can talk of obtuse angled scalene also, and it works fine. I'm just not taking it for the intent of making it simpler to understand. Okay, fine. Now you take the midpoint of each side of the triangle. Consider them as D, E, and F. The line joining the midpoint of the side to the opposite vertex is called the median. I'm repeating it, I'm not writing it. The line joining the midpoint of the side to the opposite vertex is called the median. So this is a median, which if I can draw perfectly with my superb bad drawing. So this is a median. So AD is the median. The line joining the midpoint of a side to the opposite vertex of the triangle is called the median. Similarly is BE and similarly is CF. All these medians intersect at a single point, and they do for each type of triangle. Again, I am telling you. That point is called the centroid, denoted by the symbol G, and G is reserved for the centroid of the triangle. So medians are AD, BE and CF. G is the centroid of the triangle. Centroid has a very special case also. Listen to this again. I can prove it, but for now let us leave the proof. Maybe in doubts and discussion in the Monday class, if I get the time, I will prove it. Okay. But it is done. I'm just telling you, it is done by taking the areas of each triangle and then proving that these areas, if I sum, it will be in the ratio because the base will be same, and somehow it is done using half base into height. I can draw perpendiculars and I can do that, but I'm just leaving it for now. Okay, it's a very simple proof, not difficult, but still it will make it messy, and my aim is not that. So G is centroid of the triangle, and the centroid, now listen very carefully, the centroid divides the median, divides the median in the ratio of 2:1, 2:1. Okay, and this 2 is from the vertex to the centroid, and the other side is GD, which is the centroid to the midpoint, and that ratio is 2:1, and it is true for each of the three medians. So basically BG is to GE, BG is to GE, and then CG is to GF. This is what we call as the median, sorry, the centroid property of the triangle. It divides the median in the ratio 2:1. So what it means is this will be 2, so this will be 1. Now ratio is not same as the exact measurement. You people are aware of ratio and proportion. You know that ratio is the simplest term or simplest fraction, correct? So in that, it should not be a fraction because it's, let's leave that discussion, but again, it's the simplest term, okay? You can't reduce it even further. So if the ratio is 2:1, it means it can be 4 centimeter, 2 centimeter. It can be 20 centimeter and 10 centimeter, like that. But centroid, in some cases, we also talk of centroid in case of mass in physics, and in case of regular figures, excuse me, I want to, okay. So the the thing is, yeah, centroid is center of gravity. That's what I was about to tell you, Shlok. The thing is that the centroid in that case will also represent the center of gravity of that point for all the regular kind of figures. I don't know much about it. I'm not a physics guy. I may say something wrong, and I'm stopping here. In mathematics, I know this thing, and it is purely this whole maths about median. Median derives centroid, or median is the parent for centroid to happen. If there is no median, you can't talk of centroid. Okay, you all get it? You all get it? Correct. I hope this is perfectly clear now what's the median. And please don't like make the misconception again. This should be the last day for your misconception, the last hour of your misconception. Okay, superb. Okay, now let us understand. Okay, can we draw this in geometry or not? Can you draw this or not in geometry? See, it is a very easy way of getting it. Getting a midpoint is not difficult. So if I draw a triangle, you can always get the midpoint. How so? See, either you can take up the ruler, rotate it and put it and measure the midpoint. Correct? Yes, you can do that. Or, okay, I hope no one heard that kind of loud sneeze. Okay. So now the thing is A, B, C. Or you can always use the perpendicular bisector. Now the perpendicular bisector is derived from two words, perpendicular and bisector. Bisector in math means something which divides it into two equal parts. That's called a bisector. If it is not bisecting, then we call it intersecting. Remember these two more terms in geometry: intersection or intersecting and bisecting. I have seen many kids getting confused in these two terms. Not required. Intersecting can happen in any sense. Just it means that the ratio will not be exactly 1:1. So I can say that this line is intersecting. So it can be like 4, this can be like 1. I am not sure. It can be anything. Bisecting is pretty straightforward. It means that exactly 1:1 has happened. And this has been divided into two equal parts. That's when you use a bisector. Okay. When you attach the word perpendicular to that, when you attach the word perpendicular, it means the bisecting is now happening at 90 degrees. That's the whole point of adding a perpendicular bisector. The word perpendicular means at 90 degrees. It can be at any point, but the moment the perpendicular and the bisector joins together, it becomes that it is bisecting exactly 90 degree and half, making half of the thing. Okay. So what I'm interested here is just to draw the median. Correct. Median does not care about the angle. It cares about the midpoint joining to the opposite vertex. Now, why I can't just draw the perpendicular bisector? Let it be the perpendicular bisector. Let not to be worried about it. Just we get the point. We get this point D. Now join this D. You get it? Now similarly, you can make the perpendicular bisector. Okay, you get the point E or F. Okay, E, suppose, let's say E or F, whatever you call it. So you can join this one to B. You get this median. Yes, you just make it dotted like this way so that you don't make the teacher or the person who is seeing this confused. Yes. So when in geometry, the dots are the dashed lines. are the lines which are not required for the final figure. They are the helping lines. This is the rule for it. The dashed lines are always for the helping lines. The solid lines are the main lines of the figure. Okay, the solid lines are the main lines of the figure, and those are counted in the final diagram. So I have wanted the median, so I made it a solid line. Same way I do a perpendicular here, bisector, draw it, then I got the point, let's say it F, then join it, and we get CF. Simple. You all get it? It's not drawn perfectly, that's why they are not meeting at single point, but of course they will meet at single point, and that will be G. Is it clear now? You people understood the perpendicular, the drawing of the median. Hey, I could have drawn it, but that was just unnecessary. The process is so self-explanatory now that you can go and try on your actual paper also. Okay, let's come back and do the next one. So the median is gone. Let's bring the circumcenter. Okay, so circumcenter, okay, that's the point. Okay, now the circumcenter point is the point of intersection. Okay, so point of intersection of the perpendicular bisectors. Okay, perpendicular bisectors, remember, not the perpendicular only, but the perpendicular bisectors. That point is called the circumcenter. Okay, it's always for a triangle. So remember that I have got a triangle. If I draw a perpendicular bisector of the sides, perpendicular bisectors of the sides of the triangle, you people should not be confused at any stage, okay, of triangle, sides of the triangle. Okay, perpendicular bisector of the sides of the triangle. So this is one perpendicular bisector, this is other perpendicular bisector, and this is the third perpendicular bisector. They will join. Why this is called a circumcenter? The point being, it is making a circumcircle. What it makes? A circumcircle. I so want to draw it. I thought you people were aware of these facts, but okay, fine. Circumcircle, circumcircle, circumcircle. If I break it even further, it actually means circumscribing circle. Sorry for my bad handwriting. I'm writing a little bit fast, and that's the reason. Okay, circumscribing means something which is packing. So let me change the color. Okay, fine. Okay, so if I take this as the center and take any length as the radius to the vertex, this is my radius, then I can make a circle packing this triangle inside it, and therefore it is called the circumcircle, and therefore it's called the circumcenter point. You all get it? Yes, Shruti, correct. So all of you, if you, let's see if we can make it. I just will give like 2-3 minutes, because this is a very difficult tool. It seems simple when I use it. It's not simple. Okay, let me just try to make some. Okay, okay, this one is fine. Okay, okay, we got it. Okay, we got a triangle. A triangle, you know how to make a triangle. I'm not teaching you that, by the way. This will be like then 2-3 hours of class for construction. Okay, let's make up the perpendicular bisectors now. Quickly we started. There will be a little bit of error because the lines are not perfectly joined, and it takes like that in that sense. Okay, remember you have to keep it more than half. I hope you people know that. I cannot make a dash line here, so I'm considering the lightest color I can find, the gray color. Okay, so that it does not interfere with our black color, and we perfectly get a perpendicular bisector. Okay, I hope you people understand that, and you people. So this is the point where it is struggling. Okay, no shoes. Hey, this is trouble. Oh, this is trouble. See, that's why I was saying it doesn't zoom or anything like that. Okay, I have to just make it a little bit lesser. Let's keep it more than half, but okay. I wish I can get it. I'm trying my best. I get it. Okay. So weird. It didn't touch. I wish there was an eraser also. Hey, don't go there. Okay, wait. Apologies, I told you already that this is a very fine work, and it is totally dependent on my hit and trial approach. It takes a very fine point the next time I even put it anywhere. So that's the whole trouble. Okay, I finally got this one. Okay, let us join this. Okay, so fine. We'll extend it later on when we will need it. Let's keep the next one now. I want to make a circle and I want to show you. That's the whole point of me doing all this thing. Okay, I hope you all won't mind. I've got enough space this side, so no problem here. Okay, no, it is fine. Hey, you. Stop it. Okay, finally I got it. Okay, let's take up the red line. Fine. Joint. Okay, I got the perpendicular bisectors for all three. Okay, now I have to get this one, the last one. Is it more than half? Oh, let's make it a little more half. Okay, fine, this works. This is us. Oh no. Okay, fine, this much is far. Oh, great. Finally it intersect. Don't worry about the gray lines. The gray lines are not required. There is no eraser here. The whole point being that's the whole trouble. By the way, I forgot which was the gray line I last drawn. Let me just remember that. Oh, this one. Okay, finally. Okay, this is the line. Okay, let's make it the green one. Okay, so now all of you see I've got the three lines. Those are the three perpendicular bisectors of the line segment of the sides of the triangle. I have not named the triangle, but it is not required. Let us just now quickly extend them. Okay, fine. So I'll bring my ruler because I don't want to extend in a very bad way. It will be the worst case scenario if I do that. I don't need the compass, by the way. Oh, now it is fine. So I can okay, consider that it's like little bit fine. Now I've got, so the whole idea being that if the three lines intersect at the same point, the two lines will also intersect at the same point. Okay, so if I've got the intersection point of green and blue, I don't need the intersection point for red. The red will go and meet it there only. You people are smart, you know that if they are going to meet at a single point, they will obviously extend and meet at the same point. So I'm not going to do that red extension, but you should do that, by the way. I'm just saving my time because I have to make the ruler extended like that way, and I don't want to do that. So let's just quickly remove all those things. Bring our, hey, here is our green and blue. We got that point. And if you notice, I have to just adjust it to this length because that's my radius is. It never changes. It should never change. And let's see if I get a very good uh, purple circle. Okay, let's make it. Hope it makes up the purple circle. Can you see, all of you? Your teacher just now made a circumcircle using the just a basic software. You got it? Now you all can see that proof is correct, that the perpendicular bisector gives you a circumcircle. Okay. Okay, I hope this is fine, and this is the perfect I could have got, like the complete perfect. Okay, now if you all understand a circumcenter, now let us just now do the incenter. Okay, so the incenter. Hey, I don't need this green color. Wait, I'm totally not a fan of blue gray, other than blue gray and black. Okay, so these are the three colors I use. Okay, so incenter. Okay, incenter comes from angle bisectors. From angle bisectors. Okay, now what are angle bisectors? We already covered angle bisection. I hope remember 60 degree, 30 degree, 30 degree, 15 degree, 15 degree, 7.5 degree. The starting. So you know what an angle bisector is. So it's where all the angle bisectors meet. All angle bisectors intersection point is the incenter. Okay. All angle bisectors. Which angles? The triangle, of course. Okay. And when you say incenter, it comes from the situation that I can make a incircle. Or in, if I break it even further, like the circumcircle, it breaks it into inside circle. Okay, inside means something which is inside some figure, which is what? The triangle. So what we will get is a circle touching all the sides of the triangle. All the sides, remember the two differences. The circle which touches all the vertices of the triangle is the circumcenter. The circle which touches all the sides of the triangle is the incenter. Okay, now you all know, and I hope that you understand it. If I can get this, I can also get the other one. Yes, so it looks so good. No, I don't want to clear this. Okay, but I have to do that. So I really want to do that. Okay, let's not do it. Let's see how much control Z we can do. Finally. Okay, let's now make the angle bisectors. I hope you all know the angle bisectors for any non-angle. It doesn't matter what the angle is. Angle bisector is not that you can only bisect the standard angle. It's not like this. It's totally not like this. Okay, like the perpendicular bisector, you make the length more than half, you cut it. The same thing you can do for angle bisectors also, and it works. Okay, so let's now quickly make the angle bisectors. First you have to make this. Okay, then you have to, hey, I don't use this color, wait, this should be gray. Okay, now this is the point where you go, you take, you have to bisect these, correct? So I am just bisecting it. Okay, I have got my first angle bisector. Let's quickly make a line segment. Got it? The first angle bisector. Okay, no, Shruti, the circumcenter and incenter have no same centers. That I will tell you in the last part of this. Okay, just wait for it. Okay, next we have to bisect this angle. Let's quickly do the bisector of this angle. So we do the bisector of this angle. Fine, we get this. Okay, and we get this. Generally we take more than half, but I said even if you keep the same, it works. So it is like this way. Don't worry about it. So got it. By the way, I don't need to make the third angle bisector. The reason is pretty simple. You people are smart. You know that the third will pass through the red and blue intersection. It has to. Correct? Yes, it has to. So why not just use the same opportunity and use the same point, this point. Okay, let me just properly keep it. Okay, this is fine. Now remember that the arc, the length of the circle will be this distance of the side. Okay, now you can lock it. Okay, you have to keep the same distance. Now I'm going to draw a circle again in the purple. So let's make a circle, and it will touch all the three sides. You get it? All the three sides are tangent actually to the circle. More about it you will study in class 10th, the tangent of the circle. But yeah, can you understand that now the circle touches all the three sides? Okay, and this is why the incenter comes from the angle bisectors. Superb. I hope you all got it. Great. So we covered the incenter, circumcenter. We covered the median one. I told you that you can get it, which is the centroid. There is no circle attached to it, so we don't make it. The last was the ortho center. There is no circle. It's just the ortho actually comes from the word orthogonal, and orthogonal comes from the perpendicular. It's also called, when you say orthogonal, it also means perpendicular. So that's like a similar word for this, okay, in mathematics. So more about it you'll study in the later part of 11th and 12th. So orthogonal line pair and all, but for now understand that it comes from the, how does orthocenter comes? Only from the intersection of the perpendiculars or the altitudes, intersection of altitudes. And an altitude is not the perpendicular bisector. Today you have understood this. An altitude is not the perpendicular bisector. An altitude is not the perpendicular bisector. Both are different species. Now what happens? I have to finish this thing. This is done, okay? I am giving you as a homework. Can you all draw the orthocenter? Can you find the orthocenter using geometry? Try it. Think about it. Otherwise, in the doubts and discussion, we will do this. No issues. Okay, Monday. Okay. But before that, one most important part. That is the unique case of equilateral triangle. Unique case of equilateral triangle. In case of equilateral triangle, what happens is, this triangle has everything the same. The centroid, the incenter, the circumcenter, and even the orthocenter. All are just one point. They are just one point. And that's only special case for equilateral triangles. It's not true for any other triangle. Okay. All the 4 points are the same only in case of equilateral triangle. I hope now you people have understood this. And I hope the confusion between all the points is cleared. Okay. This much we can prove through geometry, and this much I did it for today. The rest, if you have any other doubts, we can take up in the doubts and discussion. Slope. In general, orthocenter is not equal to centroid at any point. Its centroid is coming from median, orthocenter is coming from perpendicular. Those are very two different species altogether. Fine. I hope you liked this session. I hope you understood most of the things, and these are the major things we generally miss. We generally don't teach to the students in class. Even in 9th and 10th, we generally don't take up a special class for this. Hope this was helpful. And now I can sign off, and we'll see you on Monday with more good questions of linear equations and more good question of this. Those who still want to take up the screenshot of the project, here is your point. You can again take up the screenshot. Very simple. Use the volume rocker, the lower volume rocker, and the power key together. That will be the screenshot for you. Or if you have that button specifically dedicated in your mobile phone, use that. Okay, so you're telling in case of equilateral triangle. Yeah, Shlok, equilateral every point is same. This is the second last 2 point, last 2 questions. Okay. Welcome, Charan. So these are the 2. So the process is simple. You have to write the solution cleanly on a very good white sheet of paper. Prefer the white sheet of paper, otherwise plain sheet, whatever it is. Write in legible writing, proper writing. Take the proper screenshot. The photos you take in light, good light. Then you paste all the images, the 5, 6, whatever images you have. Paste it in a Word file one by one, one below one. Save the Word file with your name, Jimmy. Let's say your name and your mobile number. Save this Word file, upload this Word file in the Google Drive. Right click on the file. Once it is uploaded, click share. Then click anyone can edit. Share, copy that link. Anyone can edit, copy that link. Paste that link in the form provided in the video description of this video. Provided in the video description of this video. So you all can quickly take this, or It's in the end to submit project. There is a form in the end. You have to fill the form. Remember that to get the prizes, you need to take the screenshot of any of the questions or any of the screen of this teaching session and post it on the social media platform also with hashtag practically and hashtag summer workshop @practically app. Then only you will be eligible. If you don't see that, you will not be. And the prize is you will get a 6 month superhero subscription, which is chargeable otherwise, but you'll get it. Okay, top 10 people will get it. I hope you will be able to catch that and you'll be able to learn on practically with me, of course, if I teach you in that course. Correct. And by so other teachers, so good teachers, isn't it? So don't miss that chance. And there are other XP points which you can later in cash to buy some other courses. Okay, fine. Hope you enjoyed the session. We'll meet you in the next session. Take care.